Next problem. Given a by b is equal to c by d, prove that 3a minus 5b upon 3a plus 5b is equal to 3c minus 5d upon 3c plus 5d. Now here we observe the coefficient of a in the numerator and denominator is 3, coefficient of b is 5, c is again 3 and d is 5. Now we are given a by b is equal to c by d. So we make the coefficient of a 3 and b 5, that is multiply both the ratios by 3 upon 5 to get 3a upon 5b is equal to 3c upon 5d. Now we apply componendo dividendo to get 3a plus 5b upon 3a minus 5b is equal to 3c plus 5d upon 3c minus 5d. But we want minus on the top, so we apply invertendo and get 3a minus 5b upon 3a plus 5b is equal to 3c minus 5d upon 3c plus 5d. Here it's very important, whenever you're using the properties of ratio, please write that down that you're using so and so property. Now, next problem. If 4a plus 9b into 4c minus 9d is equal to 4a minus 9b into 4c plus 9d, we want to show that a is to b is equal to c is to d. Now, we are given the two sides are equal, so we cross multiply and get 4a plus 9b upon 4a minus 9b is equal to 4c plus 9d upon 4c minus 9d. Now, we want a upon b equals c upon d. What can we do here? Do we have converse of componendo dividendo? No, we have not learned that because it does not exist. So, in this case, we will again apply componendo dividendo, that is numerator plus denominator upon numerator minus denominator. We get 4a plus 9b plus 4a minus 9b upon 4a plus 9b minus 4a minus 9b. On the right we get 4c plus 9d plus 4c minus 9d upon 4c plus 9d minus 4c minus 9d. Now let's cancel out whatever possible. We'll be left with 8a upon 18b is equal to 8c upon 18d. Now cancel 8 and 8, 18 and 18. We have a by b is equal to c by d. That is, we have proved a is to b is equal to c is to d. Now to the next problem. Using componendo and dividendo, solve the equation root 4x plus 3 plus root x plus 1 upon root 4x plus 3 minus root x plus 1 is equal to 3 upon 2. Now in the question itself we are told using componendo dividendo solve this. So just apply componendo dividendo, that is numerator plus denominator upon numerator minus denominator. We get root 4x plus 3 plus root x plus 1 plus root 4x plus 3 minus root x plus 1 upon root 4x plus 3 plus root x plus 1 minus root 4x plus 3 minus root x plus 1, which is equal to 3 plus 2 upon 3 minus 2. Do not forget to apply componendo dividendo on the right side also. Now let's simplify the left side, cancel whatever possible. We'll be left with root 4x plus 3 plus root 4x plus 3, that gives us 2 times root 4x plus 3. Same way in the denominator we get 2 times root x plus 1, which is equal to 5 upon 1. Now we have roots on the left side, we want to get rid of them, so we square both the sides, or we can say duplicating the ratios to get 4x plus 3 upon x plus 1 is equal to 25 upon 1. Now to find x, we cross multiply. 4x plus 3 is equal to 25 times x plus 1. We get 25x plus 25. Now take x on one side. We get minus 21x is equal to 22. So x is minus 22 upon 21. Now to the next question. If a cube plus 3ab square upon 3a square b plus b cube is equal to 536 upon 193, find a upon b. Now here we are given this and we want to find a upon b. What comes to your mind? What can we do here? Whenever nothing comes to your mind, just apply componendo dividendo. Let's do that. We get a cube plus 3ab square plus 3a square b plus b cube upon a cube plus 3ab square minus 3a square b plus b cube. Now, in the left side, the numerator, does it look familiar? It is the formula of a plus b the whole cube, and in the denominator it is the formula of a minus b the whole cube. So we write that as a plus b the whole cube upon a minus b the whole cube. Now on the right side, when we apply componendo dividendo, we get 536 plus 193 upon 536 minus 193. On simplifying, 729 upon 343. Now 729, it is the cube of which number? Of 9. And 343 is the cube of 7. So we write that as 9 cube upon 7 cube. Now we have cubes on both the sides, so we can take the cube root, or we say subtriplicating the ratios, we get a plus b upon a minus b is equal to 9 upon 7. Now we want to find a upon b, so we simply cross multiply. 7a plus 7b is equal to 9a minus 9b. Take a's on one side and b's on the other to get minus 2a is equal to minus 16b. So a upon b is equal to minus 16 upon minus 2, that is 8 upon 1. So a upon b is equal to 8 upon 1. Now let's go on to the second part of this topic, which is proportion. Now what is proportion? If we are given two ratios which are equal, say A by B is equal to C by D, then A, B, C and D are said to be in proportion. Here A, B, C and D are the first, second, third and fourth proportional respectively. Here A and D are called the extreme values, whereas B and C are called the mean values. So we have product of extremes is equal to product of means. Now if we are given three quantities A, B and C in continued proportion, we write them as A upon B is equal to B upon C. We get B square is equal to AC. Here B is called the geometric mean or the mean proportional between A and C. What is B called? B is called the geometric mean or the mean proportional between A and C. Now one more possibility, if A, B, C and D, four quantities are in continued proportion, in that case we get A by B is equal to B by C is equal to C by D. Now we will be solving some problems on proportion. If three quantities A, B, C are in proportion, prove that the first to the third is the duplicate ratio of the first to the second. Let us take the three quantities as A, B and C. Now first to the third, that is A is to C, is the duplicate ratio of first to the second. First to the second is A is to B. Its duplicate will be A square is to B square. That is, we want to prove A is to C is equal to A square is to B square. Here we are given A by B is equal to B by C because the three quantities A, B and C are in continued proportion. We start with LHS, that is A by C. Now A by C can be written as A by B into B by C. The second B by C we can replace by A by B as given. So we get A square upon B square, which is RHS. Now to the next problem. If B is the mean proportional between A and C, prove that A square minus B square plus C square upon A raised to minus 2 minus B raised to minus 2 plus C raised to minus 2 is equal to B raised to 4. Now here we are given B is the mean proportional between A and C. In that case we get B square is equal to AC. So we substitute this in LHS. Let's take the LHS. Now first of all, in LHS, in the denominator, we have A raised to minus 2, B raised to minus 2 and C raised to minus 2. We write that as 1 upon A square, 1 upon B square and 1 upon C square. And then we will substitute B square as AC in the numerator and denominator. We get A square minus AC plus C square upon 1 upon A square minus 1 upon AC plus 1 upon C square. Now we take the LCM for the denominator part. That will be A square C square. So the denominator becomes C square minus AC plus A square upon A square C square. numerator as it is. Now take a square c square to the numerator because it is the denominator of the denominator that becomes the numerator. Now if you look, in the numerator we have a square minus ac plus c square, and the denominator we rearrange the terms to get a square minus ac plus c square. Now both of them are the same, so we cancel them out. We have a square c square. That is nothing but ac the whole square. Now what is ac? ac is equal to b square. So we get b square square, which is b raised to 4, which is our RHS. Next problem, if a is to b is equal to c is to d, show that a square plus c square is to ab plus cd is equal to ab plus cd is to b square plus d square. Now we are given a by b is equal to c by d, that is a, b, c, d are in proportion. Now the best way over here is we take them equal to a constant k. Always we are going to do this. Whenever we have in proportion, we will take it as a constant k. That is, we have a by b is equal to c by d is equal to k. Now a is equal to bk, c is equal to dk. What we are doing here is we will try and get rid of two variables. That is, we are writing a in terms of b and c in terms of d. So instead of 4 variables, we will be just left with 2 variables. Now we substitute a and c in the LHS and RHS. Let's start with LHS first. We have a square plus c square upon ab plus cd. Substitute a as bk and c as dk. We get bk the whole square plus dk the whole square upon bkb plus dkd. Now simplify b square k square plus d square k square upon b square k plus d square k. In the numerator, k square is common, so remove that out. We have b square plus d square left. And in the denominator, k common, remove that out. We again have b square plus d square. Now cancel b square plus d square, and k square upon k will give us k. So that's your LHS. Now same thing we'll do with RHS. RHS is ab plus cd upon b square plus d square. Again we substitute a and c. Let b and d be as it is. We get bk into b plus dk into d upon b square plus d square. From the numerator, k common outside, we are left with b square plus d square upon b square plus d square. That cancels. We have k. So we have LHS as k, RHS as k. So LHS is equal to RHS. Here's the next problem. If a by b is equal to c by d is equal to e by f, prove that a square b square plus c square d square plus e square f square upon AB cube plus CD cube plus EF cube, the whole cube is equal to ACE upon BDF. Doesn't it look interesting? Let's see how we are going to solve it. Here we are given A by B equals C by D equals E by F. Let it be equal to K. So we get A is equal to BK, C is equal to DK and E is equal to FK. Now instead of 6 variables, we are replacing 3 of them. So we will be just left with 3 variables. Let's do that first. In LHS we will get, instead of A square, we are writing B square K square. In place of C square, we are writing D square K square and E square as F square K square. So LHS becomes B square K square into B square plus D square K square into D square plus F square K square into F square. The denominator becomes BK into B cube plus DK into D cube plus FK into F cube, the whole cube. Now in the numerator, K square common. So what is left in the bracket? B raised to 4 plus D raised to 4 plus F raised to 4. In the denominator, K common outside. What is left? B raised to 4 plus D raised to 4 plus F raised to 4. Numerator, denominator, the bracket cancels. We have K square upon K, the whole cube. We get K cube. Now K cube can be written as K into K into K. The first K we replace by A by B, second K by C by D and the third K by E by F. We get ACE upon BDF, which is RHS. So we have proved LHS equals RHS. To the next problem, if A by B is equal to C by D is equal to E by F, prove that A cube plus C cube plus E cube upon B cube plus D cube plus F cube is equal to ACE upon BDF. Now the same way, we let it be equal to K. So A is equal to BK, C is equal to DK and E is equal to FK. Substitute this in LHS, we get B cube K cube plus D cube K cube plus F cube K cube upon B cube plus D cube plus F cube. We are keeping the denominator the same because we do not have a substitution for that. Now from the numerator, what is common? K cube common. We have B cube plus D cube plus F cube, which is the same as the denominator, that cancels. So we are left with K cube. Now K cube can again be written as K into K into K. First K we replace by A upon B, second K by C upon D and the third K by E upon F. We get ACE upon BDF, which is RHS.